Let's take a look at how synchronous technology can help us when we're working with assemblies. Here we've got a portion of a machine, and what I want to do is show you some of the options that are available when you need to modify or change several components at the same time. What we're going to do is we're going to go into this slide plate subassembly, and we're going to go through and look at some of the changes that we need to make for some of these different components. I'm going to hide the background components so that we can focus specifically on this top portion of the slide plate assembly. What you'll notice is when we're working with the steering wheel in the assembly environment, we can actually modify multiple components at the same time. You'll also notice that live rules still applies as we are modifying multiple components, just like it works when we're working on a single part. In the assembly environment, you'll notice that we have different select tools. We have what we call face priority or part priority. Part priority is turned on by default, and as you would expect, when you select a part or select anywhere on a part, it'll go ahead and find and highlight the entire part for us. This will allow us to do things like move the component or select it to do other things. Things that you would do in a typical traditional type environment. Maybe you want to show or hide the reference planes of that part or do something specific with that entire part. The other options that we have here, being face priority, allow us to select individual faces of individual parts. And you will only see this option if the part is a synchronous part. If this purple plate here were a traditional or a part model with ordered features, even with face priority selected, it would highlight the entire part. So again, face selection will only work with synchronous parts. Let's say, as an example, we need to make a change. We need to maybe widen the support block here on the purple component, and with that change we also need to make modifications to this bearing up here. So what you'll notice is if I select one face on one part, as you would expect, you would probably notice that Solid Edge is going to modify that part as we drag the steering wheel. And again, you'll notice Live Rules is going to automatically pop up on the bottom of the screen, and you'll notice that several things are happening. So Solid Edge is finding the symmetry in that part file. It's also finding the live rule for planar alignment. So it's modifying the other portion of the part where those planes are aligned. So again, by selecting that one face, I can modify 4 different faces. As I mentioned, as I modify that purple component, I also need to make a change to this bearing that sits on top of it. So what I can also do is select, and again I can hit spacebar to add more faces. I can select the face on that component as well. And again, I'm going to move the steering wheel just for clarification so we can see what's going on. But again, you'll notice that now I can change the faces on that bearing at the same time. So again, I'm modifying multiple components at the same time. Now, with the change in maybe the width of the support block and maybe the width of this bearing, I may also want to modify some other features. With that change, maybe I also need to adjust maybe some hole locations, maybe the same thing, the slot alignment. So again, I can select the hole, and with Selection Manager, again, this is another option found up here, I can now select a face on the slot and say recognize that feature, and it'll grab all those faces for me. So now not only am I changing the width of the support block and the bearing, but notice now also I can change hole alignment and slot alignment on those parts as well. Now again, I haven't done anything with Live Rules. Live Rules is being applied to both of the parts for which I've selected faces. Now, there are several things going on in this change that I'm making, and I may want to not have everything change as we're seeing it move dynamically. As an example, I may not want the support block or the support feature in the background be modified as I make that change. So what I can do is I'm making that change, I can turn off Live Rules with shortcut keys, just like I can in the part modeling environment. So as an example, if I turn off the planar alignment or hit P on the keyboard, that'll turn off the planar alignment so it's not going to move the faces on that other portion of the purple block. Now you'll notice that the holes are moving, and that's because we have the axial alignment live rule turned on. So again, if I hit A on the keyboard and turn that one off, now those holes back there will not move. Again, if we look closely at the bearing, we'll notice that the scallops are moving as I modify the location of the slot. I may want to keep those scallops where they are. So in this case, I can turn off the concentric live rule or hit C on the keyboard. So now I'm just modifying the entities that I selected, and live rules is not picking up those other elements. But I think what you'll notice here is you can see the power of how live rules not only works for one component, but it can work for several components, and you can make many changes to several components all at the same time while you're working here in the assembly environment. So again, I can turn on any live rule again if I hit C for concentric or P for planar or A for axial alignment. Again, you'll notice how I can make several changes to these different components simultaneously. Again, I'll turn those live rules off, and maybe we'll spread out the support block maybe 1/4 of an inch and just make that change. Some other options you have when you're working in the assembly environment is being able to replicate components very easily. What I'm going to do is I'm going to imagine that we didn't have these other guide blocks here. Let's just go ahead and delete those out of the assembly, and we'll just leave the one guide block here assembled here to this the bottom side of the purple support block. What you'll notice here is, and I'll go ahead and tell you this now, is this part was actually brought in from a different CAD system. These are not native solid edge assemblies. This was actually brought in from SolidWorks. And what I want to show you is when I select this component, notice how it has a grounded relationship. And that's typical when you bring in assemblies from other CAD systems, is it doesn't have the intelligent assembly constraints applied. And what's nice about Solid Edge is we do have a tool here called Assembly Relationship Assistant. And for the example that we're going to show, I'm just going to do this tool on 2 different components. I'm just going to show how it works. But you can actually do this on the entire assembly if you'd like. But what I'm going to do is I'm going to tell Solid Edge to look at these 2 components that I've selected. And what I want you to do is if you find mating conditions or axial alignments or planar alignments as well as offset options, go ahead and apply those assembly constraints automatically for me. And what you'll notice is instantaneously Solid Edge is going to show me that it found axial alignments between these 2 holes, and it also found mating conditions between the top face of my block and the bottom face of my purple block here. So very quickly I can have Solid Edge apply those intelligent assembly constraints automatically for me. And as I accept those, what you'll notice now when I select on this block is I now have intelligent mate and axial alignment conditions. So again, this is another tool that's available not just in synchronous technology, but this is actually available in when you're working with traditional modeling methods as well. Alright, so what else can we do in an assembly environment? Well, I also need to add 3 additional guide blocks here. And what I want to show you is how you can work with the steering wheel tool in the assembly environment to replicate parts. So what you'll notice here is when I select a component, here in my edit bar tool, I can select different options. What do I want Solid Edge to do? And what I'm going to do is use this bottom option called Remove External Relationships and Add New Relationships to Other Components. And what that means is if I was going to move this guide block from the location where it sits now to a new location, what it would do is it would remove any original assembly constraints and apply brand new ones based on where I move it from and where I move it to. Now this also works if I want to copy components. So as an example, what I can do is I can select the part, I can place the steering wheel at a reference point, and then you'll notice up here I have a copy option. And this can also be applied by hitting the Control key on your keyboard. But if I want to copy this block over to a new location and select its reference point here, what Solid Edge will do is say, well, select the parts you want to constrain to, and as I select that purple block, what it does is it adds a new block, and then also notice it automatically will apply the proper assembly constraints, mating conditions, and alignments to the holes on this side of the part. And I could do that same thing again if I want to select both of these guide blocks and copy those to the other end of the purple plate. Again, I can hold Control key down and copy those 2 and place them to their new location. And again, tell Solid Edge to constrain them to the purple block. And now I have 2 additional guide blocks here, and they also have intelligent assembly constraints. So again, you can use the steering wheel tool here in the assembly environment once again to copy components and very easily replicate and add that intelligence back into the part model, or back into the assembly in this case. One last thing here in the assembly environment to show, and what I'm going to do is I'm going to take one of these guides here, and I'm going to take the assembly constraints that we just applied, and I want to go ahead and I'm going to suppress them temporarily. So let's take that first one that we looked at. And what I'm going to do is just come down here to the assembly relationships, and let's just suppress those. Let's turn them off so that they're not in play. One other tool that's available is you can actually establish links between parts using what we call inter-part relationships. And essentially what this will do is it'll look at the geometry between components and link the geometries together. So what do I mean by that? Well, you'll notice here if I hit create inter-part relationships, the first thing it's going to do is it's going to say click on the part or sheet metal component to be driven. And in this case I want to drive the purple plate, and then it says click on the part or sheet metal component that will be driving. In this case I'll click the guide block. What it'll do is it'll look and see hole alignments, mating conditions, and essentially if anything changes relative to the position of my driving part, it'll update the driven part automatically. So in this case you'll notice if I highlight the cylinder option, it shows me that it found alignments between the cylinder and my block, and then also the cylinder or the hole in the plate, and it found several of these here in the list. And you can choose which one of these you want it to apply, but just by checking the box or not. So we'll hit update in this case, and I'm going to say save those relationships. What you'll notice here graphically, it'll show a little link symbol next to the part, letting you know that it has a link now to other components. And as I expand this up a little bit, you'll see that it will show you what it has links to. So what does that do for us? Well, if I decided I wanted to move this component, and I'll just use the steering wheel tool and I'll do a dynamic drag to a new location. Let's move this over, let's say, 1/2 inch. What you'll notice here is not only did it move this block, but it also moved the hole locations in our purple plate. Now, again, just to explain, not only did it move the hole locations for the block that we told it to, but because of live rules and the fact that all these holes are aligned, it knows that if these holes need to be moved, then so do these on this side because of the axial alignment live rule. So again, this is just one other thing you can do within the assembly environment, make a very simple change and have all of the other associated features automatically update for you. So again, this is just a few of the tools that are available when working with synchronous assemblies, and I hope you enjoyed the demonstration.